Algebra 1, Common Core, the June 2016 Regents exam. This is I believe, the 6th video in the series, the first of the part 2s. So number 25. Given that the function f of x equals 2x plus 1, find g of x if g of x equals 2 times f of x squared minus 1. These brackets are kind of like parentheses. They're saying, whatever f of x is, it's 2 times that squared minus 1. And since we are told what f of x is, that's what we want to put in place here. So it's 2 times 2x plus 1 squared minus 1. And the order of operations tells us that we need to deal with this exponent before distributing in this 2. So we're going to have to square 2x plus 1 squared. And 2x plus 1 squared is 2x plus 1 times 2x plus 1. And that's probably the trap, that people are either going to distribute the 2 first and then square, or in the process of squaring this, they're just going to square this and square this, not realizing that an exponent means the entire base, it's times itself this many times. And so we have a lot of distribution to do here. 2x times 2x is 4x squared. 2x times 1 is 2x. 1 times 2x is 2x. And 1 times 1, you might as well draw all these arcs. 1 times 1 is 1. We still have a minus 1 and a times 2 in the front. You do have some like terms in here to combine. Move down a little bit. This is going to give us then 2 times 4x squared plus 4x plus 1 minus 1. So this right here is what you get when you have 2x plus 1 squared. Now I can distribute this 2 and apply this minus 1. So distributing the 2, we get 8x squared plus 8x plus 2 minus 1. Combine my last like terms here, and I'm going to write my final answer over here, that g of x, because that's what this is 8x squared plus 8x plus 1. That's it. Now, we're into the part 2s, so these are not multiple choice, so you have to show all of your algebra, and you can get partial credit. Now, these are worth 2 points each. So if you made one little mistake somewhere, like say I messed up squaring this, but I carried everything else correctly, then you'd probably get 1 out of 2 points. Or if I distributed the 2 and then squared, I would get 1 out of 2 points. So like one mistake here, you'd still get 1 point. But if you're making 2 mistakes, now you're down to 0 points. Number 26. Determine if the product, remember product means multiply. Determine if the product of 3 rad 2 and 8 rad 18 is rational or irrational. Real quick, a review of rational, irrational. When it comes to the operations of these things, when you have a rational and a rational, working with 2 rationals, the result is always rational. It doesn't matter if you're adding, subtracting, multiplying, dividing. I mean, there are some small exceptions to the rule, but in general, 2 rationals, the result is rational. One of each, one of each, a rational and an irrational together, the result is always irrational. Does not matter if you are multiplying, dividing, adding, or subtracting. When you have a rational and an irrational, the result is always irrational. Now, how do I know if something's rational or irrational? Well, I mean, the rational numbers in general are regular numbers. But when it comes to radicals, it's the square root of a square number. So, for example, the square root of 4, the square root of 9, the square root of 16. These are considered rational because the square root of 4 is just 2. The square root of 9 is 3. The square root of 16 is 4. Any fraction, like 3 over 5, any positive or negative number, or negative 2.7, like these are rational numbers. An irrational number is something like pi, or it could be a square root of a non-square. So something that's not square. For example, the square root of 5. That is not square. There is no number times itself that's 5. So when it's one of each, it's always irrational. Here's the tricky part. That when it's 2 irrationals, the result can be rational or it could be irrational. It's never always anything. It's sometimes rational, sometimes the answer is it depends. Now looking at 3 rad 2, rad 2 is not a square, so that's irrational. 18 is not square, that's irrational. So this is the case we're talking about. So the product of 3 rad 2 and 8 rad 18 could be rational or irrational. It depends on the numbers. So what is it? Well, we need to multiply this. And when we multiply things, we multiply their common pieces. So we multiply the outside. 3 times 18 is 24. And 2 times 18 is 36. And so now we need to examine it. Is it rational or irrational? It all depends on the number in here. Is this a square? Yes, it is. The square root of 36 just equals 6. So this is rational. Explain your answer here. I would say that these two irrationals multiply to a square radical, which is rational. And remember, the word explain means write out a little bit of sentence. Justify means just show your work. If it said justify, I would have stopped here. But because it said explain, I had to write a little sentence. These two irrationals multiply to a square radical, which is rational. All right, let's try number 27. On the set of axes below, draw the graph of y equals x squared minus 4x minus 1. And determine the equation of the axis of symmetry. So the best way to draw a parabola like this is to make a table and let your calculator give you values. So I'll use blue here and make a table. And so I'm going to type it into my y equals in my calculator. X squared minus 4x minus 1. So y equals, turn my calculator on. There we go. Clear stuff from the previous problem. X squared minus 4x minus 1. Just double check that is what we're doing. Yes. Okay. And I can take a look at the graph and the table. And I mean, obviously, I'm not going to plot things like 10, 59. The graph that they give us only goes probably 8, 10 deep in every direction. So really what I'm looking for is probably this list right here. These are the points I could plot. And so I'll copy this down. So -1 to 5. So -1, 0, 1, 2, 3, 4, and 5. And then the values are going 4, -1, -4, -5, and then repeats the other way. 4, -1, -4, -5, and then repeats the other way. So -4, -1, 4. And we see that symmetry there. And right here, the point that does not repeat, that's your vertex. Let me just double check that list again. 2, -5, that was the vertex. Yep, all right. So let's graph this. -1, 4, 0, -1, 1, -4, 2, -5, and then back the other way. And let's see, does this go to 5, 10? Yeah, it goes to 10. So the other points would be like just off it a little bit, but that gives you something to shoot for when you're drawing it. Now remember, if you're not going to go all the edge, you want to put arrows. And you always want to label. You can sometimes lose points for labeling, especially if there's more than one graph. All right, so there you go. And then what is the axis of symmetry? Well, the axis of symmetry is the line that cuts this thing right down the middle. And the axis of symmetry is a vertical line. And vertical lines always start with x equals, and in this case, it's x equals 2. And it always works out that it's x equals the x value of the vertex. So the answer here is x equals 2. And I think that's enough. If it said algebraically determine the axis of symmetry, then we'd have to use a little formula. We do have a formula, it's x equals negative b over 2a. And so if they ever ask you to find the axis of symmetry algebraically, this is what you have to use. And in this case, that'd be x equals, this is a, b, and c. We're just talking about the numbers. A is 1, b is negative 4, c is negative 1. So negative b over 2a. Now, if b is negative 4, that means negative b would be positive 4 over 2 times a, which is 1. And so it would be 4 over 2, which works out again to be 2. So you can get the axis of symmetry by using the little axis of symmetry formula here, or you could find out what the vertex is, and it's just x equals the vertex. Remember, it's not y equals, it's a vertical line, x equals.